Blockchain is technology that allows data to be verified without a central authority blessing its veracity. Its most popular application is Bitcoin, but it can be used for many other applications. In this episode, we'll explain blockchain, which is actually simpler than you might think. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
Today we're talking about blockchain, which is more than just Bitcoin. It's actually a pretty impressive and important technology. Let's start with, why is it even called blockchain?
When we're working with a blockchain, we're working with a bunch of data that's linked together and split up into pieces. For those of you that come from a computer science background, think about a linked list. So let's break it down. Block and chain. The block is each of the pieces of data. The reason we're using the word chain is because the pieces of data are linked together. Now, how those pieces of data are linked together is going to be the most important thing for you to understand as we go through this episode.
That sounds pretty simple. What's special about the way that these blocks are linked?
What's special about a blockchain is we can verify that both the blocks and the links, the chain so to speak, are authentic.
How do we do that?
Well, now we have to get into something more complicated. We need to get into what a hash function is, and specifically a cryptographically secure hash function. Now, we've talked a bit about cryptography on a prior episode called What is Encryption, which I'll link to in the show notes. But for the purposes of our discussion today, we really just need to understand the concept of a cryptographically secure hash function. Now, what a hash function does is it takes some bit of data and it turns it into some fixed size, smaller piece of data. So for example, if I have a hash function that always returns 128 bytes, even if I give it a 3 megabyte MP3 file or I give it a 1 gigabyte movie file, it's going to give me 128 bytes back. What's important about a hash function is that it gives me a fairly, especially for a cryptographically secure hash function, is that it gives me a fairly unique value, as unique as possible, for every piece of data that is provided to it. We want to have as few different pieces of data end up resulting with the same hash. And the hash is what the output of the hash function, that 128 byte result in our example, is called. The other important thing about a cryptographically secure hash function is that it should not be reversible. Once I get that 128 byte hash, I should not be able to take it and recreate that 3 megabyte MP3 or that 1 gigabyte movie file. So it's a one-way transaction. I take the original data and I provide back the fixed size hash, but I can't go and take the fixed size hash and recreate the original data.
So the hash in a blockchain really serves as an identifier for that specific block.
Right, a very secure identifier for that block. So now we actually have enough information that we can get to talking about the links. So when I go from one block to the next block, what I do is I use that cryptographically secure hash function to create a hash of the prior block. The reason this is important is that, remember, each of the results of that hash function, those hashes, are unique. So if anything changed within the prior block, it would produce a different hash result. And then I can quickly verify, as somebody who is just coming across this blockchain for the first time, that each of the links is valid because I can check to see that the hash is really the result of the prior data. If somebody went and changed any of the data in one of the prior blocks, it would change the hash, and therefore it would change the hash which appears in the next block and is referring back to the prior block. So the whole blockchain, for example, could become invalid if somebody went and tried to change the data in one of the early blocks. Then all of the subsequent hashes would no longer evaluate to the same thing. So what this means is when we have a blockchain, somebody can go and verify its authenticity, or at least verify that all the links are correct and all the hashes are correct without having somebody actually say to them, hey, all of this is correct. And most blockchains are distributed. So there are multiple copies of the blockchain floating out there on different machines. And so if one person goes and tampers with one and starts changing some of the data, another person, or another machine really, that has the blockchain can go and see, well, hey, now those hashes no longer make sense. When I recalculate those hashes, they don't match with the blockchain that I have. Therefore, these are probably tampers, probably somebody going and making modifications.
So does that mean that no one can ever change the blockchain?
Well, actually, the blockchain can change. Somebody could go and modify it. It's just that everyone else would quickly realize that they did that. And so we would know that that was an invalid change because other people have copies of the blockchain and can verify that these changes that have been made on this other copy no longer match the hashes. And so it makes it pretty tamper resistant. Now, you might wonder, then how do we get new data? Well, you can add new blocks to the end of the blockchain. You might have realized by now that all of the blocks in the blockchain are in order. They're in a chronological order, basically, because as they get added with the calculation of the hash of one prior block. So you can add a new block that is, to the end of the chain. What's difficult and where this gets a lot more complicated is how do we decide what is a valid new block? Who gets to add a new block to the blockchain? Who gets to make that decision? And that is where we go from the base technology of blockchain to a more sophisticated technology that includes blockchain, that blockchain is just a subset of, like Bitcoin. Bitcoin has advanced algorithms for reaching a consensus on what is a valid new block to add to the chain. But that goes beyond just the base idea of blockchain. So the base idea of blockchain is what we described before, and it is at the core of Bitcoin. But Bitcoin also includes so much more. But we can use this base idea of blockchain for other applications beyond just Bitcoin.
Like what?
I think one of the most interesting applications of blockchain is in the supply chain. So how do we verify that as a good moves from a seller to a receiver, maybe it's a middle person who then actually sells it to somebody else, that it is actually the authentic good? And how do we also verify that all of the transactions are valid? And how do we keep those records in a very, very secure manner? And how can we even do that without the expense of having a central authority or a third party verify all the transactions? Blockchain can make that possible.
Let's talk about an example.
Okay, so let's say that you bought a Picasso painting from Christie's auction house. And let's say you bought it for $1 million. And I don't really know if Picassos go for $1 million. I think they probably go for a lot more than that. But let's just say you bought it. Okay? And then you sold it to me later on. Let's talk about how the blockchain might work here. So, hypothetically, Christie's would have created what's called the Genesis block. That's the first block in the chain. And they would have recorded a few different things. They might have recorded what the item is. So it was a Picasso painting. Maybe the painting was called The Bull or something like that. Okay. It was The Bull by Picasso. And it has a little information about, actual data about the painting. And then it also has a timestamp, which would be when maybe they started the blockchain. Okay. And when they created this first block, it has this time and date of when it was created. And then they also have some kind of signatures, really that you can authenticate and say, this is really Christie's who created this initial Genesis block. And then what happens is you buy it from them. So you're actually going to be adding a new block to the chain. And your block to the chain is going to include a timestamp when you bought it. Maybe it'll also include some data such as how much you paid for it. Maybe you paid that $1 million for it. And then it's also going to include a hash of the previous block. So it's going to include a hash of the Genesis block that was created by Christie's. Now, you sold it to me. I bought it from you, let's say, later on for $2 million. We added then another block to the chain. My block now includes, again, some kind of signature of me. And by the way, I don't know if I mentioned that your block contains a signature of you, so we can verify that it was really you that owned it. So some identifiable verification that it was really you. Now, mine includes that for me. Maybe includes some data, how much I spent, maybe 2 million, the timestamp when I bought it, and it also includes a hash of the prior block, which was the block that you created. So that's the link back in time. So now we have 2 backlinks going all the way back to the Genesis block that Christie's created. Now, why is this interesting? Now, if I now want to sell the Picasso, other people want to buy it from me. They want to know that I really own the real Picasso. First of all, am I the real owner? That's number one. And number 2, is it the real thing? How do they know that I didn't just make up this Picasso or get a copy of it made or just say that this is where it came from but didn't really come from there? If this blockchain is actually somewhat widely distributed, they can check, they can go see, do the other copies of this blockchain match up with the hashes that Dave's blockchain has? If I went and changed anything, then the hash values would be different, and then the last block on it would no longer make sense. It wouldn't match up with the other copies of the blockchain. So in this really simple scenario, we would need some way of distributing the blockchain amongst other partners. And then some of those partners, if there was going to be a central authority, might need to be trusted partners. So let me give you an example. In this scenario, maybe Christie's is the trusted partner, and they have a copy of the original blockchain, and they might actually be keeping records of the additional blocks that are being added to the chain. Therefore, they're a trusted central authority. But if we just did that, that would actually defeat the purpose of it being distributed and not relying on a central authority. Once we start having multiple copies of the block all over, let's say, some kind of network, then we need to have some kind of way of consensus showing what is the valid blockchain. And if somebody goes and forks it, saying that that's actually not one of the valid blockchains. And that kind of goes beyond the scope of our discussion today, and that goes again back into the realm of something like Bitcoin. But you could see how, if we had this, it would be useful to be able to know that I really am the owner of the painting right now, and these really are all of the prior transactions that went on that link it all the way back through all the owners back to the original seller, Christie's.
Would certainly help with art fraud.
Right, absolutely. So what gets complicated here again is how we actually go and distribute the different blockchains. How do we come into consensus? And there are multiple different schemes for this. Bitcoin has one particular way of coming to consensus of how we verify that we have new valid blocks. And that's really beyond just the base technology of blockchain. And Christie's might choose to go with a non-distributed methodology. They might actually say, you know what, people trust Christie's, and we're going to be the centralized authority that maintains the validity of the blockchain. That is then a little bit of a different scenario in that you don't need such an advanced algorithm for coming to consensus on what is a valid new addition to the chain and what is not, and what's really the valid chain. You instead just need to rely on that you trust this one authority, which is Christie's in this instance. And so the pros and cons of that are that the pro is that it's a lot simpler, okay? It actually requires a lot fewer machines, and it requires a much less sophisticated algorithm. And so you're going to save on some energy, you're going to save on some complexity. The downside is, once it's no longer distributed and you're not using that sophisticated algorithm, there is one central point of failure. If Christie's ceases to exist, who verifies the blockchains? If Christie's gets tampered with, what happens then? So it's much more powerful if we actually add on those overlays, those consensus algorithms, to really allow us to distribute the blockchain amongst many different machines, because then we don't have this problem of a central authority that can potentially either be corrupted in some way or even cease to exist.
Is there anything else our listeners should know about blockchain?
Well, I hope what you see from this is that the base idea of blockchain is really quite simple. Where it gets tricky is how we go and distribute the blockchain and decide on what are valid new additions to the blockchain. So there's been so much buzzword-driven reporting and even new companies popping up over the last decade around blockchain. And now that you know that blockchain is really a pretty simple concept, hopefully you realize that maybe some of the hype has been a little bit unfounded. There certainly are really interesting applications of it in many different areas. Of course, cryptocurrency, which we could spend many, many episodes on, we could spend the rest of our lives talking about, is one of the very interesting applications of blockchain. But just blockchain on its own, while a powerful technology, requires more to really make it a very useful technology in the way that Bitcoin exists. Blockchain is the base technology that Bitcoin is built on top of, but there's a lot of other important ideas on top of just the idea of blockchain. And I think what's very confusing for a lot of people learning about blockchain is that often resources that teach about it conflate the two. They start talking about that next step, about how we verify who can add a new block to the chain and how we come to some kind of consensus about the chain. And that really actually is not just the base idea of blockchain. And for the programmers out there, I want to mention another blockchain to you, which is actually Git. We talked about Git on a prior episode that I'll link to in the show notes on version control systems, GitHub, and Git. In Git, every branch, and for the people who don't know what Git is, you can just tune out for a second here, but every branch is basically a blockchain, and every commit is like a new block. And all the commits actually follow in chronological order, and they are connected to the prior commit. And so we really have a blockchain in Git. In fact, every time you have several different branches, you have multiple different chains. So blockchain even has an application in version control. All right, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll talk to you in 2 weeks.
Bye.